You can get 300 right there in those three, and then you're going to go look at the Ks. So the Ks won't make sense, I don't think, until tomorrow. And I might extend that deadline until after spring break, but I think we should be able to do it. And I'll give you some more time in class to get those done. But let's come look at the notes. Pages 4, 5, and 6 are all kind of notes, and then we're going to practice them on 7 through 10. And hopefully this will make sense for your homework tonight. Basically, there are a bunch of different ways that we can label things, right? And we're going to have to use the vocabulary that we've learned up until now, and then do like a so what almost. So if I tell you that M is the midpoint of something, you know M is in the middle. Because of that, the so what, the therefore, those 3 dots, right, is that KM is congruent to ML. So if I tell you M is the midpoint, what I need you to pull from your head is if it's a midpoint, then there's 2 equal segments, right? M is in the middle, so the left side equals the right side. I won't always tell you KM equals ML. I need you to infer that, okay? So you're going to want to go back to these notes and kind of remember, oh, midpoint means that's in the middle. If it's in the middle, then I've got a left and a right, and the left and the right are equal. Same thing if it says bisects. So this one, the language can get a little tricky. I want you to give yourself a visual. BD is a knife, okay? BD is a knife, and it's cutting this triangular piece of cake. So BD cuts AC. This is the thing that's been cut. AC has been cut in half. That means AB equals BC. This first thing stays intact. When you slice a piece of cake, your knife doesn't cut in half. Your knife stays intact. You can wash it and reuse it a million times. Okay? So the first thing is the knife that cuts the second thing in half. We're going to get that wrong a couple of times before we finally realize that we need to figure that out, okay? The first thing is the knife that cuts the second thing in half. So AB equals BC. Then we've got this thing called the reflexive property. You had the reflexive property in algebra. It just meant that whatever was on the right was also on the left, right? They equal each other. Well, it's the same thing in geometry. I've got a K triangle, and it's attached, it's adjacent to an M triangle. This JL side is like a wall on this side and a wall on this side that occupy the same space. So if you have something that's stuck together, then LJ in the K triangle and LJ in the M triangle are the same. It kind of makes sense until you start doing the work we're going to do, and then you're going to be like, what the heck, right? You can always mark these things. If you're told midpoint, you can always mark the 2 sides, the left and the right, equal. If I tell you that something has bisected something else, then that something else has been cut in half. And if they occupy the same space, then you can always mark those things, okay? So those are the first 3. Let's look at the next 3. You can also mark angles in a similar way. So we've got vertical angles. Vertical angles are always congruent. So angle P on the left side equals angle P on the right side. That's kind of difficult. It's not very specific, right? So that's where we have to label it with 3 letters. So this left P is NPL. I look at that middle letter to look for my vertex, but N and L tell me it's the left side. That's why we have to name it with 3 letters, okay? Then I've got P on the right side. I'm still looking for P. That's my vertex. That's my angle. The M and the O are contrasting it to the left side. So M and O are on the right side. So I'm talking about the P angle on the right side. MPO. Okay, that's my vertex. Vertical angles, you always have an angle that's the same. Then I've got an angle bisector. So again, BD is the knife that cuts this second thing in half, but this time it's not a side, it's an angle. So I've got angle D, that's my vertex. I'm just being super specific about it because I've got 3 angles here. If I don't say ADC, then maybe I'm talking about the top or the bottom. So that whole angle is cut in half. That means the top angle, ADB, that's vertex is still at D, It's just the top angle. So that's why I have to use the A. And then BDC is the bottom angle. It's still angle D. It's just the bottom angle, right? So that's why we have to use those 3 letters. So I can tell the difference between the whole angle, the top angle, and the bottom angle. Does that make sense to everybody? Because sometimes it's a struggle. Literally, I just imagine myself, this is a big park, right? And I'm walking from B to D to C. That means I'm in the bottom part of the triangle. I'm walking from A to D to B. That's the top part of the triangle. And A to D to C, that's the whole triangle, that whole angle. Okay. So vertical angles always congruent. Angle bisectors always cut something in half. So in this case, the top part and the bottom part are going to be congruent. Then this right angle congruency theorem is just kind of, it makes sense until you start working and then you're like, oh wait, I forgot, right angles are always 90 degrees. Right angles are always 90 degrees, okay? Right angles always 90 degrees. So angle G is congruent to angle K. Here I don't need this real specific 3-letter naming. We just did it because everything else was named with 3 letters. So angle G equals angle K. They both equal 90 degrees. A lot of times when we start doing algebra problems in geometry, we forget that this little box means 90. I would encourage you to always write that 90 somewhere when you're writing that right angle. Okay? Questions? Just basic definitions, right? We're going to use this vocabulary. There's always a so what. This is where it starts getting a little crazy. Okay? It's a little hard to look at. If I have 2 triangles that overlap, I've got an ABE triangle. It's a little acute triangle over here on the left side, and I've got DCB over here on the right side. They overlap, right? So angle B in the A triangle is exactly the same as angle B in the C triangle. That's the reflexive property. So reflexive property works for both sides and angles. If something occupies the same space, exactly, they're congruent. Okay. If you're given parallel lines, you usually get angles as a result. Okay. Let me say that again. If you're given parallel lines, you usually get angles as a result. If I know that these lines are parallel, QT and SR, and remember that's what those little arrows mean, then my alternate interior angles are congruent. The green angles make a Z. Can you imagine if I'm drawing on that, that makes a Z? And then the blue angles also make a Z. Okay, so angle Y equals angle S. Those are alternate interior angles. You can make a Z this direction, or you can make a Z this direction. Oh, I didn't do it the other direction. Well, the other way, this way, right? Forget I did that. Alternate interior angles, and then corresponding angles. You guys are the best class I've ever had at identifying corresponding angles. So if I know that SV is parallel to UW, and you can extend those lines if you want, if that makes it easier to see, I can slide U right on top of S and S right on top of U. Those are corresponding angles. They're connected by this SUT transversal. Okay. All right, let's look at some examples. I'm kind of trying to keep a track of time. So if I tell you T is the midpoint of RP, what does that tell you? What's the so what? What's the so what? Trying to get my chat to pop up. What do I know? Because T is the midpoint of RP. Yeah, which sides are congruent? RT is congruent to TP, and those are sides, right? I love that you said they were sides. So then what else do I know? I know ST and QT, ST and QT, so I can mark those. Those are also sides, right? And then I can go to this last one, SR and QP, SR and QP. And that's also sides, right? So what did I mark here? If I just look at one triangle, so I'm just looking at this right triangle, what's marked? A side, and then a side, and then a side. This is going to become important tomorrow. Side, side, side. We've got to know whether we mark sides or angles. I know this sounds really basic. When we start working tomorrow, you're going to see why this is important, okay? So if you're not taking notes, please, please, please take some notes. Do it on the Pear Deck, do it on the Google Slides, do it on a piece of paper. I don't care where you do it. You just need to write this down. You've got to physically mark these triangles. Otherwise, you are going to be confused in this unit. So here we've got YK equals TN. So YK equals TN. What did I just mark? Sides or angles? Sides, absolutely. I know this seems ridiculous that I'm asking this. I promise it's going to be important. Just stick with me. Then I've got YU equals TI equals TI. Did I just mark sides or angles? Sides, absolutely. So then I come over here. What on earth does that notation mean? What's this symbol? Perpendicular. So YK is perpendicular to UK. What does that mean? YK is perpendicular to UK. What's this? So what? It's not. Is K the midpoint? What does it mean when I say perpendicular? What's the so what from perpendicular? It's a right angle. Absolutely. So I'm giving you segments here, but what I'm coming away with is an angle. Right? It's not enough to just translate. You've got to then give me a so what. So then over here, TN is also perpendicular to NI. TN is perpendicular to NI. That also gives me an angle. I've got 4 segments here, but what they're producing is 2 angles because perpendicular means right angles 90 degrees. So what do I have marked if I just look at one triangle? I've got a side, and I've got a side, and I've got an angle. We're going to find out tomorrow that this does not mean that this triangle is congruent to this triangle, because if you spell a word reading that backwards, we can't do that in math. Okay? Not allowed. What about this one? What do I mark? Sides or angles? Sides, absolutely. What about this? G is the midpoint of FH. What's the so what if I know G is the midpoint of FH? What's congruent? FG and GH. If G is the midpoint, then the left side and the right side are congruent. So FG is congruent, that means congruent to GH. Okay? And that's also a side. What else can I mark? There's one more thing I can mark, because those 2 triangles, the F triangle and the H triangle, are adjacent. If they're adjacent, what's reflexive? JG and JG. JG is in the F triangle and JG is shared with the H triangle. They're like 2 weird triangular townhouses stuck together. So JG is congruent. Whoops, there's supposed to be a JG in there. And that's another side. Side, side, side is always going to work. Side, side, side. Right? I can prove those triangles are congruent. That is an S. I don't have any numbers on here. Thanks for the clarification, though. I'm always amazed at my handwriting on this thing. All right, last one. So BHL and AHL, what angles are those? BHL. If I look at that middle angle, that's H. Middle angle, that's H. I've got 3 angles down here. I've got a big angle, a left angle, and a right angle. So if I go from B to H to L, B to H to L, that's my left side. This one is my left side. And then AHL, AHL, this is my right side. Right? So that's an angle. If LH bisects angle BLA, what comes out of that? What's the so what? LH is the knife that cuts BLA. BLA is this angle. So what's the so what statement? What can I write? Yeah. Absolutely. So BLH, angle BLH, that left side is congruent to the right side, ALH, angle ALH. Okay, and that's another angle. So I've got an angle and an angle. What's the third thing that I can mark here? Because I can always mark this thing because it occupies the same space. Absolutely, I love that language. So that line that bisects the 2 angles, that LH line, is the reflexive side. So side LH is congruent to side LH because of that reflexive property. And that's a side. So I've got an angle marked, and a side marked. And the side is in the middle. So when I go to put these letters in order, I don't go in order that I put them. I go in order that I see them in the triangle. Just like I would name angle BLH in order, you've got to do that here. So I've got an angle, and then a side in the middle, and then another angle down here. So when we go to name this tomorrow, it's going to be angle, side, angle, because that's the order it is in the triangle. You always got to go back to your triangle to look for the order. Okay? All right, so let's talk about homework. There is a green puzzle piece homework in here. Please, 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 please do that before you come to class tomorrow. That is the priority, this green puzzle piece homework. After that green puzzle piece, go do the JIXLs. You should be able to do J1, J2, and J3 at least to 80%, in an ideal world to 100%. It will make your life easier tomorrow if you do it to 100%. But you do have until Friday to do that. And then tomorrow we'll talk about this delta math. Okay, so this 10-question homework is priority. Working on the JIXLs is the second. All right, questions about today? No, don't work on the delta math until tomorrow, unless you want to. Like if you're bored and you want to do math, go for it. But we'll look at that tomorrow. Homework, this green puzzle piece, and then the IXLs. Okay?